Hello everyone and welcome to our 23rd POP webinar, the SME Perspective. So today we are going to talk about experience of some European SMEs on use of HPC and what sort of barriers they had to deal with and what are the supports that is available, and also we are going to discuss what sort of support is missing. There are a couple of European initiatives that are funded by EU to support SMEs, and POP project is one of them. A lot of you are regular attendants at our POP webinars, and so you're familiar with POP, but I will give an overview of the POP for those people who are joining us for this webinar. I am Fujan Hosseini from NAG, one of the partners of the POP project, and it's my pleasure to host three panelists, Marco, Gerald, and Benedict from three European SMEs, Optimat, TIC, and hydrotech. So let's start with a short overview of POP. Performance optimization and productivity, or in short POP, is a center of excellence in HPC and is funded by EU under Horizon 2020 Research and Innovation Program. The mission of POP is to help EU organizations to improve the performance of their parallel code. And for all of you who are attending this webinar, I hope I don't need to really convince you the business case for it. Better parallel codes means better use of computing resources or HPC infrastructures, means faster results and more novel solutions, or reduce expenditure. And if anything, the last year and a half and the pandemic has shown all of us, or has reminded all of us, of the importance of HPC in helping us to deal with the challenges that our society is facing. POP is a partnership of 8 commercial and academic organizations with excellence in and a lot of experience in performance optimization, in developing performance tools and programming models, and also working with a lot of HPC applications. POP has a methodology for performance assessment, and it sits in the heart of all of our activities. Today, I'm not going to go into details about it. We are very proud of it, and if you are interested to know more about systematic performance assessment, I suggest you to have a look on our website and learn about this methodology. We also work on open source tools and for performance profiling and tracing, and we work with the whole community, from users who use the workstations to users that run huge simulation on HPC centers. We work with all the other Center of Excellence in HPC, with academic users, SMEs, or large industrials. And we provide 2 types of services. We have a POP performance assessment, which we basically assess an application and find what are the issues, the main issues that limits the performance or scalability of that code. And in a follow-up service proof of concept, we help our customers. We provide practical help with code refactoring to address those issues. So the 3 of our panelists today, they all have experience working with POP. They either in the past or they are currently are working with us. So I say no more about POP, and I will ask them just to set the scene and start the discussion, to share with us their story and what was their experience. And meanwhile, if you have any question, please submit them via the question the question panel in GoToWebinar. So our first speaker is Gerald Eisenberg from TIC. thank you for being here, and over to you.
Yes, thank you, Fusan, and welcome everybody. My name is Gerald Eisenberg from firma TEAK, Geophysics, and I'm going to present a little bit about our company and myself first. TEAK Geophysics, as it's seen from outside, is actually inside a group of very small companies. The whole alliance of companies listed here actually still are an SME enterprise size in international and national standards. So it looks big, but it's very small. In total, we are about 35 people distributed over these companies. So there are more illegal issues. So they should be more seen like departments of one company. That's how we look outside. And I'm actually from TechWare, the software and research and development division of TEC. And here with TEC and TechWare, we look back at 30 years of experience in cluster computing, starting with artificial intelligence, neural network originally. The group here involved in POP is the experts team from R&D for the code implementation for the cluster services. TEC itself, to the outside, is a solution provider for seismic service and beyond. I've written most of it is still the seismic service. That's our core ability, where we work and operate worldwide for seismic data analysis and interpretation. From our head office in Isernhagen in Hanover in Germany, we and some small offices and local partners over the world, we actually work with data from all over the world. So how come that it's small, tiny company from in the middle of nowhere in Germany can actually operate worldwide? The answer to this question is we look into unique technologies written on the bottom line of this slide. The reason is we try to be one step ahead of the mainstream service providers in this sector. The way we do that, this is just the house of what we provide: seismic processing, reservoir characterization. Probably not that, but the way we do that is that we work closely together with universities, with consortia in research, and have a number of ongoing research projects to try and be that one step ahead. What we do from the physical perspective, we're looking at data that other people gather. We're not doing the data acquisition ourselves, but we get data from seismic surveys, either onshore, offshore. Here a marine example where a seismic source is released and energy is submitted into the sub-bottom and in the subsurface, and is reflected from various layers, subsurface layers, and then back recorded on the hydrophones. And the main task is to provide geological models that represent the subsurface in order to find these layers where you can find gas, oil. That's one of the main business, but also structures which are relevant for geothermal, shallow construction site development, and other applications, pipeline routing, and so forth. The key issue is that from these measurements, there's an example on the bottom of this slide. We need to do and run an inversion process and do many simulations to come up with the model best known. So that's the computational expensive part. And we try to highlight from the seismic data relevant features, which are here like a fracture system for geothermal, where is faulting in the subsurface to then derive geological information. Originally, a lot of effort is done in this computational work because drilling a dry well for in oil and gas exploration costs millions of dollars. $10 million a well is normal. So in this respect, a lot of money can be spent in providing better geological and geophysically interpretable data. So that's why our algorithms are actually a lot of effort is put in to provide very sophisticated algorithms, which probably in many other commercial aspects you would not be able to spend this amount of time and effort to provide these. The computational efforts we do is many of the simulations, finite difference modeling, frequency domain modeling, and the most expensive part is usually the inversion process, where we have to run many of these simulations to simultaneous optimization, for example, in 8D parameter space of a 3D volume. So that is the computational tasks where we run these on these parallel systems in an HPC environment, sometimes, usually rather on heterogeneous Linux clusters in-house in our base. So the other issue is that we work with very large data volumes. Conventional seismic surveys have hundreds of gigabytes or even terabyte scale of input data. So it's not only computational expensive, it's also large data volumes. And that's we're not really focusing that much on the HPC environment, rather than what we are looking into is the many task computing problem, looking into the exascale development. That's really interesting for us because a lot more than the very high computational effort is even the large data volumes to look through, input output. And that's, of course, to run these simulations, efficient computing of large data is a key to success. And that's why we got interested in the POP service and find that very useful to assess whether our code is actually optimal and can be even optimized further in order to provide that. So we took some recent code from the research consortia, which had little in-house adaptation at TEC, slight optimizations, but not that many, and see how these codes are scaling already on HPC systems, and the POP service assessment stage there attested that the code actually is already in very good shape for parallel computing on HPC systems, which is good. And currently we're testing the same for heterogeneous systems and other bottlenecks related to that. So far, even so, we have no gain in performance with the assessment, but we are very confident. We have a large gain in confidence that we are doing a good job with our jobs. That's very important for us. And we are learning new tools to make the code optimization easier. So that's also very helpful, and we are grateful for this service. So that's for the time being. I'm happy to answer more questions and see how we go. Thank you.
Thank you very much for that nice short summary. Now let's go to Marco Gestanino from Optimad, the senior software developer in Optimad.
Good morning, everybody. My name is Marco Gestanino. I'm a senior software developer at Optimad. Optimad is a small enterprise founded in 2006 as a spin-off from the Department of Aerospace Engineering at the Polytechnic of Italy. Its mission has always been to provide excellence in fluid dynamics and scientific computing, and in order to achieve this ambitious goal, Optimad built a staff that at the moment counts 10 PhDs and 3 Masters of Science, 3 PhD students and 1 market and sale manager. During its history, Optimad gained an important experience in scientific computing, and 3 leading-edge proprietary tools are the outcome this accumulated experience. They are at different level of development, and they are not still on the market, but quite close to. They are Longbox, which is an expert system for engineering, which is in the making process. Mimic, which is a computer-aided surface manipulator and mesh morpher. And Immerflow, which is an hybrid open MPI plus OpenMP parallel solver based on immersive boundary method. And Immerflow was the object of the work done with the context of our project. In Optimat HPC, many concern our flow solver Immerflow and generally speaking, CFD analysis. Currently, industrial standard in CFD simulation, especially for SMEs, is based on cheap turbulence model like grants, which suffer of low reliability and the need for abstract interpretation of the resulting to give physical value to them. At the same time, industry is changing their need, looking for a more expensive and reliable model, but the high simulation cost could be a limit for the budgets of SMEs or for the budgets devoted to cheap or non-strategic products. We definitely see, you can see in this slide how the cost of a simulation of a wing at Reynolds 5 million increase by moving towards more reliable turbulence model. That's why in Optimat we see HPC services like POP a way to reduce this economical cost, making parallel codes more and more efficient, and in some way democratizing the access to high fidelity simulations. During our experience in POP project, we worked with NAG on the assessment and improvement of the performance of Immerflow. The performance assessment carried out by NAG put in evidence a good scaling behavior up to 760 cores, but at the same time, it discovered the reason for a scaling degradation at 1534 cores. But more importantly, this assessment gives us the idea of the issue of the OpenMP version of the code, which has a poor performance at a number of threads. NAG helped us to discover that this was due to atomic clock contention. So following the suggestion NAG gave us with the proof of concept, we worked a lot on the structure of the code, introducing OpenMP test loops and removing some temporary data copies. This gave us a better way to overlap communication and calculation that gave us a 10% performance improvement. And basically, we recovered the poor scaling the hybrid code was showing, giving us an overall efficient improvements at a number of threads. But most importantly, the most important aspect the work we NAG gave us is a very deep insight in our code parallel behavior and on the hotspots of the code, which at the moment is laying the ground for future efficiency improvements like GPU porting. That's it. Thank you for your attention.
Thank you very much, Marco. I'm very glad to hear it was our services was helpful. Let's go to Benedict, Head of Software Development at hydrotech.
Yeah, thank you, Susan, for having me here. Some insights about hydrotech and the way we use POP. First, Hydrotech is based in Germany. It's near Belgium, Netherlands border at the 3-country point, and some nice stuffs and even sweets from Germany. Nice to show you this too. What are we doing? The name says hydrotech, water technology. We are working in water management, especially flooding, sewage water. We are responsible for planning and consulting. Our company has about 60 employees. It contains civil engineers and software development. Myself, I'm the head of the software development. Our programs contain simulation programs, mainly on hydraulics and hydrology. And yeah, for sure, we just heard it, additional services surround this geographic information systems database web. We have some products, but for now I will stick to HydroAS. HydroAS is a model for simulation of runoff and to compute water level. What do we get as input? We get ground elevation, soil properties. Is this grass or is this asphalt or whatever? We get the amount of water which comes into this area by inflow or by precipitation. And HydroAS computes in every place water level, the vector velocity of flow, times along the time. Yeah. We do this by creating models. These models have different sizes. It's regular small, but realistic, not no school model is about 100,000 nodes. Let's say a regular model is about 2 million nodes, and for us, big models about 100 million nodes. Therefore, the computation time also varies depending on the time you need to simulate, depending on the size of the model, depending on some other topics, and it's between, let's say, 30 minutes and up to 2 weeks. And if we come in this area of 2 weeks, we see that performance is an important point. We do these calculations, at least in HydroAS 2D with fortran, and we are using our programs on Windows and Linux. Who are our customers and what do they do? So myself, I'm the head of the software development. One of our main customers is my own company, the colleagues of the civil engineers, but also external customers. We provide our software, water authorities and private companies, civil engineering companies. They often make small models and they often have just a few and occasional users, which are not full-time modelers, but along their work, they have to build, let's say, a model some weeks, for one model in a month, or it's not often, it's just a part of the work. And also we have consulting engineering companies like ourselves. We also build these small models, but also huge models. And we have many users who consider themselves as modeling professionals. The usage pattern is edit and create the meshes and boundary conditions usually on Windows workstations. Computations is often made just on the same Windows workstations or maybe on Linux workstations, especially if you go to this, let's say, smaller models and smaller civil engineering companies. It's just a desktop PC, and the post-processing is done on Windows workstations and also in the web. To give you a feeling about what the software does is here's our this is a website, and you see the river Erft, which flows from the south to the north, and you can see here in one time step, like, let's say, the Erft, the river goes from south to the north, and you see that here it floods over a dam and floods into the rest of the area. And the particle animation, I hope it's possible to see this on the internet. with the internet, you see where is it fast and in which direction it goes. Yeah, that's a typical result of Hydras. What are our parallelization techniques? Mainly multi-threading with OpenMP. We're using Intel. Less well known in this community is maybe this GPU approach, OpenACC. It is pretty much a fortran or a C++ C extension, pretty much like OpenMP, very equivalent. If you do so, we are able to, with some, let's say, tricks in conditional compilation, to maintain one source for both flavors. It's nice. It's important for us. We get GPU code which runs on many kernels, like powerful GPUs do. All in all, we have, as I explained to you, we have many customers which don't maintain a great IT department. For them, stability, easy to use is very important. All in all, GPU is less stable in different setting of the customers. Let's say they get a new GPU and we get problems. For now, we don't use MPI since most of our users do not have access to cluster machines, and we try to avoid the maintenance for additional code and maintaining many more software architectures. For now, it has a lower priority than other topics. The POP process. The POP process was performed by the High Performance Computing group at the IT Center at the RWTH Aachen at the Aachen University. The persons we had the pleasure to talk to, Fabian Orland and Julian Miller, which I use the opportunity to say thank you, Fabian and Julian. You did a great job. So they got some results on OpenMP, made these pictures we saw from Marco, similar. We detected that our software is memory bound. They found an uncached I/O problem, which I was surprised we have, but at least it was easy to solve. And they looked that we enforced the usage of SIMD. The work itself was performed here at Hydrotech office. That was before Corona, before May 22. People came one day a week for some months. And we had some very concrete support. That was good. But even more, I appreciate the side effects. We got training and advice on the usage of the Intel tools, for example. This OpenACC approach I just mentioned is a very high level approach to GPU programming. So sometimes we didn't have a very good clue of the inside, how the connection between GPU and CPU works. Generally, ACC has, we use ACC not to care about these inside, but sometimes you have to care. And these people from the High Performance Group at RWTH Aachen do have a very profound understanding of these insights of OpenACC and of OpenMP and of the way the Intel optimizers work, and on the way what's useful to look into and where just let it stick to the things the compiler does by its own. And also, let's say the reason was about the reason we came here were for this parallelization, but it's also interesting to talk to them on any algorithmic aspect they go to other people who have similar problems, and it's great to talk with them. And I learned a lot about this whole topic from them. It was great, yeah. So beyond the specific advice on this program, increase in general knowledge at hydrotech, and our wish is to stay connected with these people and maybe I can't say some concrete reason we need them at this problem, but it's always a great insight. So thank you.
Thank you very much, Benedict. One of our goals as part of specifically the POP performance proof of concept service is this kind of transfer of knowledge, of like helping people to get more insight, and I'm very glad that we were able to achieve that. It was great to hear all these diverse experiences about use of HPC. One of the good things about working from POP is that we get to work with people from different domains, and as you can see, it's all these different applications use HPC to answer real problems and find solutions. I want to remind our audience, if you have any question, please start submitting your questions to the question panel in the GoToWebinar interface. So I want to just kick off the discussion with what Benedict mentioned about, use of GPUs or using heterogeneous computing, and this kind of disturb. Does it disturb your workflow when new technology arrives and SMEs have more limited resources? Did you have any kind of problems there, like how to address this? Do you prefer to, for example, stay to what you have? Is it difficult to make changes, make cases for using the new technology? What is your view basically, or experience on this?
This OpenACC GPU stuff. Yeah, sure. We have to invest to learn all this stuff, and it is a new kind of thinking. This SIMD calculations. You think you know about parallelization, but that's again something different. You have to learn new the concepts, and not only the concepts. It's also some how can I say, some very deep computer internal problems about pointers, invalid pointers and this stuff. And for example, at this point, these POP guys were a great support for us. For us, it is important to, or it is at least a great advantage to have one source code and to maintain only just one program. I don't know whether I answered the question.
Yeah, I just want to hear people's experience. Yeah.
Okay.
So that was, thank you, Marco or Gerald, do you wanna?
Yes, for sure. When this new type of, talking about GPU, this new type of completely different architectures come on the market, and not only on the market, but come into HPC clusters where we buy resources, and then if you are not able to exploit this acceleration, you are buying more. You're spending more money than you can exploit the machine. But fortunately, we basically, for sure, we need to think and rethink again about this movement towards these new architectures. We need to learn, and we need to understand without knowing if the investment in this kind of architecture can have a return in our business. But fortunately, there's a lot of public institution initiative that can help you in learning and in working on your code. At the moment, we were granted by the first UCC project, and we present exactly the porting on GPU. So the kickoff was yesterday. So
okay, great. So you get some like help in the project to help you basically migrate to GPU. Gerald, do you have these sort of questions or issues to deal with? I think you mentioned you have in-house.
It's certainly always a difficult decision to have a long-term decision on new hardware and new perspectives in computing power and how the hardware develops, how the demand develops. And of course, it's always sometimes it would be good to have a discussion group to have more input or knowledge, because it already takes a lot of time to just gather the information to be able to take some of these decisions. For example, we use for our GPU programming, we decided not to use the very common CUDA platform for NVIDIA GPUs because we wanted to be independent of a hardware company and used OpenCL, but then we have the problem of sometimes it's much harder to get access to all the memory which is there. Then you're quite frustrated sometimes if you buy large-scale GPUs which have large memory and you can't access it because the framework doesn't allow it. So that's really a lot of problems you would rather like to not have to bother about, but daily life is different. And of course now maybe knowing and having that there are experts that you could actually ask for help, and that is probably not there are other people in the same problems could be interesting. Even so, we find that usually the questions we have, most people don't have a solution yet either. So then they always say, okay, you have to wait or you have to do it yourself. We cannot help you there. So we'll at the decision of does it pay to actually put effort into that or not. So if we find people that could even help us more and maybe avoid some of these additional work, that would be great.
So you touch on this community, existence of a community that they share the same problems, or can maybe use that community as a resource to find answer. So we know there is an HPC community, and that involves a lot of people coming from different domains and having computational science codes or engineering problems and so on. Do you think that community kind of do you feel part of the HPC community, or do you mostly feel part of the community of your domain application? And does that so for example, somebody might be using parallel code, but they might feel being part of engineering domain and they might not find enough support. So your company is all aware of HPC, but do you see that issues in any of your domains?
Well, I can think definitely no, we don't see ourselves as part of HPC community, because most of the HPC problems are relating to really just computational expenses and not that much large data volumes. So a lot of the problems we have in network traffic, input-output traffic, are not the questions that people in HPC communities talk about. That's other problems we have. It's not the computing power is not the only thing for us, and most of the times not the most important thing.
Okay.
Again, I completely agree. We are more part of our domain community than HPC, but it has to be said that we still have some strong connection with the HPC community, and I have to admit that there's a lot of availability from them in Attendees, even if they are not in the domain. And sometimes you can find people in the HPC that comes from your domain. This is probably the best situation. What I think it's completely lacking is a kind of community domain-based, but more interested to the HPC discussion. And this is something, for example, it's lacking in experience. We talk with the HPC engineer. Sometimes they are expert of CFD, but sometimes.
Okay, interesting. Yep.
For sure, we are also part of the water management community and less a part of the HPC community. And but I just stressed that it was great to learn to this community. And if you have any ideas how to stabilize this kind of platform, we'll be there. Yeah.
Yeah. So let's then take it from there. Like, so this, we could provide this service because it's, you know, funded by EU for this purpose, and it has started in 2015. Obviously, it was successful, and as well was funded for another round, and the current project is funded till end of May 2022. So if the terms was a bit different, like, so here it was no money exchanging, you know, we could collaborate without worrying about the financial side of things. Would, you know, if that was not the case, then would this, you know, impacted your decisions? Would you be able to start this collaboration without knowing, you know, in terms of, for example, in case of Gerald, they did the assessment and it was useful because it, you know, raised the confidence that the code is performing well. And I know that could be very valuable because then, you know, you shouldn't spend your resources in optimizing the code more. But then how does that work? Can you convince them, you know, the higher up in management, or, you know, that you need this kind of collaboration and you need to pay for it, for example? Or how is, yeah.
So it asks, yes, we would have paid. For us, it's quite easy to say because we first started to talk to the HPC people of the Aachen University, and we have some kind of consulting with paying a person. And then these guys came up and said, hey, there's a way to give it a frame, let's say, and furthermore, it's even without any cost to us, but it would have been worth money, yes. If you talk about the amount of money, hard to say, but generally it does not have, there's no need to be just for free. Yeah? Absolutely. Yeah.
But the question for us, yes, it was interesting and very good to know and have the confidence, but to be honest, I don't think there would be a way to get funding for such an assessment unless there really is an urgent need for optimization that you can address, that you say, okay, if we cannot be more efficient with that type of computational service, then we cannot do it because the market will not allow you to get more money. We have to either be more efficient or quit the service. Then of course there would be a point where management would say, okay, if we can't do it ourselves, or maybe if we've done everything we can, maybe it would be good to have another opinion and try to get the rest out of it and then decide before we quit a service. But just for the comfort of knowing that our job is well done, it would probably be difficult to convince management to provide funding for such a service.
Yeah, and you often don't know where to, you know, before start, you kind of know, you don't know the answer, kind of. So yeah, so Marco, what was?
Yes, I completely agree with Gerald. It's a critical decision for sure. It always depends on the investment and the return of the operation. Sometimes it's mandatory because sometimes your code is not behaving as you expect, and you need to do a kind of assessment in order to understand what's going on. But we would prefer to learn to do it. Then again, thanks to you for this kind of experience, and thanks to all the other actors we play with. Think about Cineca, think about situation, public situation. We always try to not buy a service, but a service with something we can learn to do by ourselves. If this is the case, the budget is completely different. Our time and the time still part of the enterprise, and we can manage better the budget. That's why.
You always try to like extend your in-house expertise in the domain because. Okay.
I would fully agree with that. That's that would be the main point and a valuable point. If we can show that there will be in-house again in in-house expertise, and that is a long-term investment, not only for a small project and for one solution, but it's a long-term thing, then of course that's very interesting.
At the same time, sometimes it's not possible. You cannot get all the experience you have, for example, now. But at least we need to do the effort and see if this investment in learning is good for software. So critical moment of the development of software itself.
That's an interesting, you know, that's interesting because I think that's common between all the three of you, because Benedict also was very much into like, you know, learning from getting insight. Yeah, so thank you for sharing that. That's actually one of in terms of what is a bottleneck for SMEs in like to take up more on SME on use of HPC. That's one of the things that is usually mentioned, like if the management is not aware of the potential benefit of HPC, but also lack of in-house expertise, and then difficulties in raising finance to support that. So to just now we are getting to the quite close to the end of the time that we had, unfortunately. So to wrap up, I just want to ask what you see in the coming years, and you know, now or in the next 5 years, you think would be the most most important barrier for your company or your organization to use HPC, and how like a project or a public funded project like POP can try to address that.
Maybe I can start from one perspective, even so. Let me put it that way. I think it's one of the most important challenges I expect in the next couple of years, and that is the change in or development in hardware available for computing, going to more and more cores, more parallelism in small units. You mentioned the exascale computing things, or the difference between GPU and CPU will probably disappear, and they will all, we have really many tasks in parallel. So there is, I think, the challenge in getting the code we have and the code we need into a stage where we not count on there are single CPU that will be coming faster and faster. I think that time is over. It's more going into parallel. So more and more jobs have to be broken down into small units in the many tasks. I don't see that much a problem from our scale because we're already addressing this problem for about 2 or 3 years and redeveloping our software. But I see that this will probably be one of the big tasks for small companies in the years to come.
I would say that I can see, from a certain point of view, I can see a huge barrier in accessing HPC from a certain point of view in the company. From another point of view, the point of view of the solver, for example, for VMflow, I'm quite, I wouldn't say scared, but quite about the needs to be compliant to the heterogeneity of the new machine. This is something that we are approaching now. Using GPU doesn't mean use completely the machine, it's just use the GPU. So this is the aspect we are starting exploring now, how to approach completely and fully exploiting the power of these new machines in our flow cell. This is something that we are discovering now, and as any discovery, that's some small fear.
Yeah, that's indeed challenging. Hopefully something like POP can be helpful there in transferring knowledge. Benedict, what are your thoughts?
Sorry, I don't have really, I'm not so anxious about learning these things in the future, even if there are some lags, because there are many great programs to learn these kind of things. To me, I think we have more potential in enhancing our algorithms independently of the way it is parallelized. Compute less, compute more intelligent instead of compute parallel. But this parallel stuff will for sure be, always an important topic. Yeah. But I would focus on better algorithms.
Yeah, actually that's a good point, because even if you're using the parallel hardware, the best way to get most outcome from it is to have a good parallel algorithm as well. Yes. So thank you very much, Marco, Gerald, and Benedict. It was really a pleasure to have you here. Thank you for your time and sharing your experience with us and all our audience. We are looking forward to work with you in future, and for any of people in the audience, if they are interested to use POP services, just head on the POP web page and you just a 5-minute it's a form that just takes 5 minutes to fill in the service, and then we will be in touch with you.
Thank you for that.
Thank you. Have a good
Thank
day.
You,
Bye. Thank you.
Bye.
Bye-bye.
Bye.